Hello, everybody. Welcome to another stream. So this game I picked up on Steam. It looked interesting. I've not played it at all, so we're going to play it together. And if it's terrible, I don't know, we'll play something else. We'll see. We'll see what it's like. Oh my goodness. That's loud. Calm down. What is happening? Let's see if it's gonna put that back. Will it show up when I... No. No, I have to... Oh. Never mind. There it goes. It's just delayed. Okay. So it's called the Signal State. Uh-huh. Puzzle Workshop. Alright, that's a new game. Ah. Our machine stopped working years ago. Not just ours, everyone's. Our computers, our appliances, everything. Oh, that's it. Turn the stream's over. Everything stopped working. No one knows why. Entire cities ground to a halt. That comma shouldn't be there. I wasn't even born when it happened. All I can remember were the distant dark cities hidden in smog. So here we are. Building everything from scratch, putting the pieces in the right places. Okay. My radio crackles to life. You should be nearly there. Do you see it? Hold on. Yeah, I think I do. Ah, beautiful. Welcome to the rural life. Wow, it's in quite a state. That's where you come in. That farm's your home now, and it needs some fixing. Oh no, this is like a 51st kilometer kind of situation. Okay, get out there. You gotta make a new farm. You gotta make a new city. Yeah, here's like 2 crates of food. That's all you get. Guess I should settle down and get started. Yes, you're going to be alone for now, but hopefully not for long. Why, are you not going to call? Can you call me every day? I might go stir crazy. Go 4-3 build! Well, thanks. It's like, sorry. Sorry. That's the name of the game. Okay. I thought everything stopped working. How come I have a tablet? Hey, it's me. All settled in. Well, yes, but I'm still not sure why I'm here. Yeah, I like not knocked on the head. I don't know anything. Okay, that's fine. Our scouts found the farm you're at right now some weeks ago. So we sent you out. As you can see, it's in a state of disrepair, and you need to get it back up and running again. With it running, we'll have 2 farms, we'll have more food, more space for our community. 2 farms, okay? Like, this is the second one. They've already done this once. How do I do that? All the machines on the farm are going to need to have their internal electronics rewired. That's your job now. We sent you with our own personal modular rewiring system. With it, you can design circuits that will emulate the behavior of the broken components within the machines. You're going to hack and repair these machines so that we can get them up, this farm up and running again. With it, we can produce more food and support more people. So I'm guessing that's what they did. That's how come I have an iPad. They recycled an iPad. How does the rewiring work? It's easier if I show it to you. We have to recalibrate your system anyway, so the sooner we begin, the sooner you'll understand how it works, shall we? Okay. Details. This is a diagnostic test to verify that the signal pipeline works. Connect SRC1 directly to both out 1 and out 2. Okay, I should be able to do that. This is your job. Rewire the circuits to repair the machine. Okay. Start with a given source, SRC, transform them, and send them to the out sockets. The brief describes your objectives for this circuit. For this circuit, you have to send the SRC1 signal to both out 1 and out 2. Oh, look, even in the future, everything's still made in China. Use the transform signal. Use the modules to transform signals. Connect them with the cables. Click and drag on the sockets to create the cables. White sockets are inputs. Black sockets are outputs. Okay. Inputs can only be connected to outputs. Well, that makes sense. Try now. Connect to SRC1 to the split. Okay. Oh. Click. A split takes in one signal and duplicates it to multiple output signals. Okay. 1, 2. Press play to begin signal playback and verify your solution. Oh yeah. That sounds nice. Yay! That's a very high score. It's a very high score for dragging 3 wires around. How the hell is there a leaderboard for the intro level? It's all the same score! Excellent, your system works perfectly. You're ready to begin. So what now? Start cataloging the machinery on site. Start with the simpler ones. I'm sorry, I can't do this. I'm not sure I can do this. Always start with the specs. Read them carefully. Understand the problem. Oh no, I gotta look at the specifications. Look at the tools you have available. Learn what they're capable of. Soon you'll start to see certain patterns repeat themselves. And if you're ever stuck, you can always ask me for help. Okay. Okay. Power generator. The work begins. So what's the end game here? Why are we repairing this farm? We already have our current one and it's giving us enough food. Well, we will have a surplus food and more space for our community for one. But I think we can do more than that. Oh yeah. By the way, I'm just going to eat a pizza in the microphone. Nothing you can do about it. More. It's too early, I think, to talk about that at this juncture. Not everyone here agrees with me on the plan. Not yet, at least. Oh, I'm on a black op or something. Not even a hint. I'm the one doing the work out here. I deserve that at least. You're right. Look. And for the last few years, we've subsisted just fine. But is that all this we can do as a community? Probably. No. What are you talking about? I'm talking about rebirth, not about rebuilding. It's not enough to survive. That's all I'll say for now. Okay, whatever. I guess the first thing to work on will be the on-site power generator. Good plan. That looks like an Ellis Agritech generator. Should be easy enough to rewire. What's Ellis Agritech? Hey, it's my favorite SS13 YouTuber live. Hey, Digby. Hope you're doing well. No SS13 tonight. Instead, it's this. A corporation from the old world, probably the biggest manufacturer of agricultural equipment. Rare is it. Rare is the farm without an Ellis Agritech machinery. Okay. Send SRC1 to out 1, but the signal intensity tripled. Okay. Let's go. I guess I need an amplifier. Some. Well, if I'm going to triple it, then I guess I just do that, right? Let's see. I don't know if that's... Yay! Yeah, everybody scores the same because there's only one way to do that. Good job. I expect you'll have a lot more Ellis equipment to deal with on your farm. Is that a problem? No, not really. It's just Ellis Agrotech is a name with historical baggage, shall we say. Sure. Goodbye! Circuit breaker. Taking the heads. Sure. Great, now the generator is up and running. It's time to reroute power to the various power lines with a circuit breaker. Alright. Output 1 receives SR1 signals increased by 5 volts. Output 2 receives SRC1 signal with its intensity halved. A module catalog shows what modules are available for the circuit. Read the descriptions to understand their behaviors. Click and drag on any module. This could be like a Space Station 13 minigame, you know? Click and drag on any module in the module catalog to add it to the rack. Try it now. Add the attenuator module to the rack. Or it takes the input and reduces its intensity, inverts it, or both. Click and drag existing modules away from the rack to delete them. Hey. Some modules have adjustable controls. Oh, there we go. Knobs can also be adjusted with the scroll wheel or by typing into the numeric display. Use these buttons to toggle between the module catalog and the I/O. Signals are limited to a range of negative 100 volts to 100 volts. How do you have negative 100 volts? Try solving a circuit on your own. Good luck. Okay. So let's see. Out 1 increased by 5 volts. So that's a bias. What does bias do? What's a bias do? Takes the input and shifts it by a constant offset value if there's no input. Bias outputs the offset value. Oops. Takes the input and reduces its intensity, inverts it, or both. Let's see. Output 1 receives SRC1 signal increased by 5 volts. Well, we have to split it because we have multiple outputs. Okay. And then receives its intensity halved. That'll be 50%, I guess. I'm assuming I know how that works, but I probably don't. This part I still don't. Bow, 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 bow. Okay, so output 1 looks fine, but output 2 is not quite right. Try putting it at 50 instead. So I don't know what negative 50 does. Yay! Excellent. The tuner is now able to efficiently route power to whatever systems that need it. Time for your next step. Great. Oh yes, got to hook up the lights. That's obviously harder than making a circuit breaker. Lighting circuitry is not too complicated. Some voltage levels have to be altered to prevent blowing the lights out. That's good. It's been pretty creepy here at night. Well, you're right to be cautious. There might be strangers out in the wilds, and they may not have the best of intentions. Don't worry about it. I'll hook a cable up to them. I'll plug them into the cables. Okay. The system contains some functions meant for your convenience. You can change the playback. Yeah. Cables can be color-coded for organizational purposes. Right-click on an existing color cable. You can ask me for hints if you're stuck. The notepad and oscilloscope modules are useful for debugging and experimenting. Always remember to read your brief for your objectives. Aha. Last 8. Okay. So let's see. Output 1 will need to be SRC1 and SRC2 summed together. Output 2 is SRC2 subtracted from SRC1. Okay, what's going to be a sum split that. Blip. All right, so that's output 1 done. Yeah, SRC2 is SRC2 subtracted from SRC1. So you can invert it by using this thing, I think, right? Let's see. Oh, you know what? I actually need to split them again. I need both. There we go. Now, I need another sum module. So invert it by 100%. So SRC2 and SRC1, and then the output is here. So what that should do is that this will invert it. So it'll be a negative amount, and when you add a negative, then that's just like subtracting it, right? And then this, I don't know, let's see what happens. Yay! There we go. Oh, I'm starting to see some shifts. Some people have been able to lower the amount of cables in that somehow. Am I expected to work nights as well? No. But if you don't want to die of loneliness, you will. Oh, okay. Some of these machines are going to need new modules to add to your environment system. I'll let Gordon build one around a butt pillar. Yeah. I'll let Gordon deliver them to you when the time comes. Gordon? You met him briefly before heading out. I'll let him introduce himself later. I didn't meet anybody. We've already established I banged my head, and I don't know why I'm here. A VCA test. Gordon. Hello, it's me, Gordon Lee. We met briefly before you departed headquarters. I issued you your modular... Yes, wonderful. I sent a delivery drone over to you with some new modules last night. Did you get it? Yes, you woke me up. Thank you very much. I apologize. Just thought you might want some new modules fresh out of the workshop. Oh, yes. Does the freshness make a difference? Absolutely not. Okay, good to know. What are these modules? These are the voltage-controlled amplifiers, also as VCAs. Are you familiar with them? No. VCAs control the intensity or amplitude of a signal with another signal. The other signal, or control voltage, or CV, is treated as a percentage value from 0 to 100, and then multiplied with the input. At 0, this is completely muted. At 100, this is completely any percentage between the two. The input signal has a reduced value. Basically, think of the ECA like a faucet that controls water flow, except you control the water flow with another water flow. Okay, I'm not quite sure I understand it. Yeah, I don't get it. That's fine. These fans just to dive right in and experiment. Hook them up here and observe their behavior. See what values they output. Don't worry, you won't break anything. Oh. Hold on, I gotta go ban somebody. I'm gonna use this one, I think. Alright, if you're ever unsure, you can always ping us for help. Alright, I'll try. Alright, here we go. At each timestamp, out1 receives a specified percentage SRC1 signal. The percentage value is specified by SRC2. Although it doesn't really... Oh, that just shows you the same thing as over here. You can see the numbers. Interesting. Great job, you're a natural. Well, it doesn't feel that way. That's just imposter syndrome. Hey, I just heard from Gordon. Good work. You'll be well on your way to getting the farm back to its usual glory. Thanks. Thank you. Everybody knows that barn lights are very finicky. Way harder to wire than regular lights. More lights to jumpstart. The barn lights are a bit more complicated. They have variable intensity controls for when the horses get grumpy, I guess. Give it a shot. SRC1 to out 1, but with intensity boosted by 50%. Send SRC1 to out 2, but with intensity boosted by a percentage specified by SRC2. Signal playback will pause each breakpoint, allowing you to visually debug your flow. You don't see. Oh, that's useful. Okay. Let's see, what do we got? I think I'm gonna need one of these dudes. I think that's boosted. That's not this one, right? Yeah, no, this one just is a wrong number. Let's see. Send SRC1 to out 2 with intensity. SRC1 to out 2. Like that. Is that it? I don't know. Let's find out. Oh no. Bah, 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 bah. Wait a minute, were they both, no? Okay. Let's see. City boosted by 50%. Yeah, when it's 0, of course, it works fine. SRC 110. You mean 100% then? No. Oh, it's 10 over, because it was 5 over before. So... oh, get rid of that. Okay. Like, it feels like I shouldn't even be using this. Get out of here. You know what? Let's try using this thing. Da da da. Okay, here, we'll put that back in here. Put that out there. Let's see. Let's see. -2, 6. Input. Okay, hold on. Stop. Here, let's put that one there. So this will be the straight signal, and then this is the... I'm not sure I understand what this thing's supposed to be doing. Well, that is what it's supposed to do, yeah, 18.9. But it's not boosted, it's... Okay, I'm just being dumb. Alright, I know what I need to do. Okay, so this is... It's supposed to boost it by 50%, but this is just halving it. So what you want to do, actually, is take that, and then put it into a sum module. Put that in here. And then I'll put that there. Oops, I don't want that there. And that go there. So that should fix that, right? Because now it's adding by 50%. See? Yeah, that one's working now. The top one's working. Man, barn lights sure are pretty crazy. Engineering the game, basically. So 20... It's not 50% more. Oh, yeah, it is. Yeah, 20 plus 10 is 30. Okay, so that's fine. That's working fine. Now, but with its produced by percentage specified by SRC2. So, we've got SRC1 working. So we don't need that anymore. Hook that up. Plug that there in. Alright, so now I need another splitter panel for SRC2. Here, I'll put Signal 2 stuff down here. That way things are a little bit neater. So put that in, because I would like to see what the value is. The split value, or the split value. I want to see what the raw value is. And I would like to see the final value before piping it out. Alright, now we can see. All right. 30. -2. -5. Okay. Oh, hold on. What am I doing? So SRC1 to out 2 with intensity boosted by percentage specified by. Let's see. So SRC1's going in. Okay, hold on. I want. Actually, I literally just hooked up 2 cables that have the same thing. Okay. Let's see. So signal 1 is at 40. -12. And this is 5, -5. I don't quite understand how this thing works. The percentage amount of input signal to send to the output. Current value is 40, which is the strength of signal 2. So it sends 40% of the signal. Is that doing that? I guess. Why is it not 6? Says it's 6 over. Oh man, I wonder if we'll get logic gates, and then we have to start like checking, like, is the signal negative or not? Let's see. So that's 0. Let's see. 12, 40%. Yeah, that's well, half of 12 is 6, so, 5, sure. But that's not... How about 216? Eh? Expecting 6. Oh. Let's see. 40. So 12. Oh, boosted. I'm dumb. See, that's the problem. I gotta use my brain. So you gotta use a sum module. Because it's gotta be boosted. I want to keep my diagnostics, please. So what we'll do is change that to here. Put 1. This. You know what? Actually, I probably don't need to be doing this anymore. That one's fine. Yeah. I think I wasn't using my brain. That's all. Wasn't reading. That's my problem. Get out of here. Okay. So we actually don't need this. Okay. So do I even need to split this? No, I don't. Just plug that into there. Plug that into there. And the output's there. And we add it together. And then we put it out. So that should be correct. Now, you know what? Yay! We did it! Oh, it even has a little indicator. Yay! Great job of finding a horse. I know where to bring him now. A horse would be nice indeed. I want to eat it. Let me eat the horse. A firmware programmer. Before getting pros, we need to repair the workshop's firmware program, a vital piece of kit for burning firmware on some more advanced modules. It's digital and operates with binary signals. The VCA can still be useful, though. You can use it like a gate. Like a gate. Our VCAs alter the intensity of the input signal of another signal called the CV. Well, if the CV is only ever 0 volts or 100, then the amplitude of the input signal isn't really changed. Instead, the input signals pass through or completely muted. Okay, cool. SRC2 is a binary signal. Oh, hello. Let's see. SRC2 is a binary signal. When it is at 100 volts, sends SRC1 to out1. Otherwise, sends 0 volts. SRC2. Okay, looks like I mean, it can't be that simple, can it? Uh-huh. Wow. There we go. We did it. It wasn't. That was just a tutorial on how you use it like a gate. We're still doing tutorial stuff. There you go, simple enough. The real challenge with using VCAs as gates is why it's generating the CV signals. You need to generate a signal at a value that's 100 volts when you want it, and at 0 volts anytime, and nothing in between. Sounds simple enough. Not always. It can be a bit tricky. You'll see soon enough. Oh no. Can't wait. I'm enthusiastic. I'm excited. Power regulator. The power regulator on the firmware programmer is a bit more complicated. It's a dual transistor circuit, so you have to check the binary values of 2 different signals. How am I going to do that? It's not too difficult. Just give it a shot and we'll be here to help. Oh yeah. Thank you. SR2 and SR3 are binary signals when they're both at 100 volts. Ah, it's an AND, so I need to make an AND gate. I thought they would start doing stuff like this. Well, if it's an AND gate, then probably the easiest way to do it. So SR1, SR2. That goes in there, there, and then out. Because if they're both binary signals, then if either of them are 0 in this setup, the signal will get canceled. Even if the other one's 100, it doesn't matter because it'll get canceled. Yeah. Yay! We did it! Alright. So that's an AND gate. Nice work. Yay. Thanks. Logic test. Oh yeah, here we go. Firmware programmers working logic modules. Sure, let's go. Now, here we go. I skipped the tutorial of this. Let's see if I can figure it out. Oh, well, it's got a little thing here. Logic modules take 1 or 2 inputs and output a binary signal. 0 or 100 volts, depending on the binary state of the inputs, i.e., are the input signals more than 0 volts or not? If SRC1 and SR2 are both 100 volts, send 100 volts out. Otherwise, send 0 volts out. All right, well, okay, so we got to do a bunch of logic tests. Let's see here. Let's see. SRC1, SRC2. Alright, 100 volts and 100 volts out. One or two inputs. Binary signals mail. Let's see. SRC1, SRC2. Alright, 100 volts. Send them 0 volts. Oh, and not. If the input signal is more than 0 volts, this module outputs 0 volts. Or else it'll output. Okay. Interesting. More than 0 volts. 100. Okay, it looks like we're only dealing with 100 and zeros. We're just dealing with binaries. They sure got into binary logic pretty quick, you know. Let's see. SRC1, SRC2, 100 volts and 100 volts out. Okay, so we're gonna need some splitters. No doubt about that. This can be 1, this can be 2. Alright, so test 1 will be AND. Wait a minute. Okay, no. Because we are doing... Okay, so output 1 is the AND. Output 2 is OR. And output 3 is the NOT. You know what we'll do? Use a sum. There. That should do it, right? Those are interesting sounds. Beep, 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 beep. Fantastic. Logic models are really powerful. You're not just doing basic math, though. You can change how signals flow with logic. Wow! In what way is that more powerful? Ha! You'll see soon enough. Right. Gordon's just like a huge nerd. He's like, I'm going back to my Venn diagram. People who are cool, one circle, and you in a completely separate circle. I guess that would be a knot. Okay, so here we're going to need min and max modules. Okay, what do these do? Min takes 2 inputs and outputs the smaller of the 2. Max does the outputs bigger. Okay, that was merely kind of obvious. Yep. I've done programming before. I know what min and max do. Okay. SRC1, SRC2, and SRC are all random signals. Out1 receives the greatest signal of the 3 SRC signals, and Out2 receives the smallest. Okay. Well, oh, that's cool. This little thing, this little flower's down, it's up on the max one. Well, because we have SRC3, might have to use some splitters in between, actually. Let's see, SRC1. Get out of here. Okay, wait. Okay. Is this Eurohack the game? Basically. I'm becoming Master Hacker. There we go. Smallest. Yeah, so I need the splitter. Because, guess I'll need 3 splitters. 3. Alright. So 1, 2, 3. And then the max. It's like Eurohack combined with my old job messing around with radio transmitters. That's what it's like. Oh, you know what? I should probably just, like... There. Whoa! Yeah. All right, you got it. Anyway, enough hand holding. Let's try more complex circuits. Oh no! Oh come on, where's the enthusiasm? I moved the 2 circles of you and cool people even further apart. Now you're really uncool. You're like an exclusive knot now. I don't like Gordon. I trust Gordon's done his job well. You should be familiar with the VCAs. Yeah. Good, we now move on to the next step. We need to prepare the crop fields for planting. That's not how Venn diagrams work. This will require a functioning irrigation system. How do we fix that? First goal is a central pump. It provides very precise rate of water flow. You need to regulate the flow using given controls. Given the concept you learned so far, VCA's gating and logic. Okay. All right. When SRC2 and SRC3 are at 100 volts, send SRC1 to out 1. If either of them are out of volts, send the inverse of SRC to out 1. If both SRC2 and SRC3 are at 0, send 0 to out 1. You're essentially creating separate universes or something. They're exclusively, not groups. That's all. All right. When SR and SRC3 send SRC1 to out 1. Okay, I'm just going to create these. I'm just going to put these boards in, these 3 splitter boards in now, because I have a feeling I'm going to need them. Okay. So SRC2 and SS. So that's an SR. That's an AND gate then. So 2 and 3. Then we just want to send. So that'll be this thing. So 1. Okay, so hold on. We only have one output. If either SRC2... maybe a sum module. Well, this will be 0. So if they're AND, it'll send SRC1. If either SRC2 or 3, let's see, SRC2 or 3. So this one will be 0. Send the inverse. So I'm going to need 2 splitter ports for SRC1, aren't I? Out. And out. If both are 0, send 0 volts. So, so we'll add 2, 3 together. Will they just invert it? No. Hold on. If both send 0 volts, if they're both, well, that might already be happening. Because hold on. Hold on a moment. Actually, you know how you can do it. I basically just want this to be... I want this to act as an override. Okay, so no. What you do is you use another gate at the end. That'll be the third test. It's got to go through here. Like that. Because then, when it comes in here, this one... If these are both 0, then this will output, well, no, output 100. It'll be output the whole signal. You'd want to output 0 if output, not the input signal is output of 0. Else outputs 100. Okay, wait. I might have to create an inverter. How would you do that? Volts. This module outputs 100 volts. Which would just be 100% of the signal. But the main problem is that it would. that wouldn't work, I don't think. Send 0 volts. Let's see, SRC1, SRC2. So the OR gate, so the OR condition is tested here and inverts. Although if they were both 0, wouldn't this just output 0? Either. Hold on. I think that would just... Yeah, I don't need to do a NOT test, I don't think. This would output 0. What would this output? Well, if it was 0 here... I don't know. I don't think that is correct. I think it's not going to work. Sometimes it works. Okay. So that's an AND. SRC2. SRC1 to out 1. When SRC2 are at 100 volts, send SRC1 to out 1. Well, that's what happened. What? It's expecting 0. Oh no, it's expecting 78. But I sent 0. Okay, the number in red is the number that I sent. Okay. So let's see. Let's follow it. So 100 is coming into here, the AND gate. And 100 comes in through here. You know what I'll do? I'll just put it on slow mode. Let's see. So that's 100. That's passing the signal through. Oh. Okay, wait. This is outputting 100. So that's why these are negating. Why would they be doing that? Let's read the OR module again. Well, I guess because they're both 100. Input signals. Volts. Okay, hold on. If either, but not both. If an input signal is more than 0 volts, Signal is more than 0 volts. This module outputs 0 volts. Oh. Okay, hold on here. And so yeah, you don't want. So if either 0, 2, or 3, but not both, are set at 100. So I wonder how I'm gonna do that. Because yeah, I gotta test for either one and then send the inverse, but I don't want to mess up this one. Okay. Well, what you can do is if both inputs are more than 0 volts, 100 volts. So well, then yeah, do that. We'll have to make a second gate, basically. Bleh. Bleh. I need another splitter too. I'm getting complex. Splitter here. Okay, so actually, I don't want to split it based on this signal. I want to split it based on this output. That way, if the AND condition is true, the NOT gate will automatically disable the OR condition, which creates an XOR gate, exclusive OR. So actually, you don't want the splitter to be on that. You want the splitter to be with that. And then that still goes here. So what that does, let's see if that works. Yeah, because it nullified it. No. I sent negative 18 instead of 0. So SRC2 was 0. SRC3 was 100. Let's see. So it was another OR gate, but for some reason I sent 0. Okay, now I'm basically doing unit tests. All right, let's see, 3 goes up here to 100. 100 goes here. 0 goes there. This outputs 0 because the AND condition isn't true, so that locks that out. So then 18 goes up here, it's 100%. This one's so 18. Oh. Helps if you hook up your machinery, stupid. Try it again. Gotta plug your wires in. Gotta plug the wires in there. There we go. Excellent work, thanks. Can you hear the water flowing through the pump? That's the sound of life right there. Exciting. Indeed. Now that the pump is working, you'll need to rebuild the distribution circuit. The circuit takes the water flow and distributes it to different... Okay. I'll read it on the screen, on the other screen. Irrigation distribution circuit. SR1 is an input signal. SR2 and 3 are CV signals for 2 separate VCAs that control the intensity of SR1. If SR1's intensity is higher when controlled by SRC2, send SR1, SR2 to out1. Otherwise, send SR1 controlled by SR3. Okay, so I guess first we have to create our... So we're basically creating like greater than, less than filters now. Let's see. So I guess first, I'm probably going to need these. I have a feeling I'm going to need them. Maybe I won't. Alright, so we've got signal 1 and signal 2. Blip. 3. Okay. There we go. Now, how are we going to compare? We've got to basically find a way to compare them. Oh yeah, max and min, that's right. I forgot I had these. Okay. Is that it? Yeah. Whee! That wasn't bad. Somebody got 2 extra points somehow. The irrigation system's running. So the last step for the irrigation system. Circuit is central irrigation controller. Receive the signals from the main pump. And okay, once I'm done here, what do I got to do now? You'll see. I don't know. I'm getting some like GLaDOS vibes from that. It's like after you're done all that, you die. When the signal from SRC1, source 1, is more than 25, out 1 receives 100 volts. Otherwise, it receives 0. Out 2 checks the value of SRC1 signal after it has been decreased by 25 volts. If the signal is still more than 0, out 2 receives 100 volts. Otherwise, it receives SRC1 decreased by 25 volts. What? Oh, okay, I see. It's subtract, but it could still, yeah, because it was like 26, it would be like 1. Okay. Okay. At first I'm like, wait a minute, like, what? Alright. So, signal is more than 25. How are we going to test for that? Bias, what's the offset value? So, okay, so this is what we can use. So this is what we can use to generate our 25. Let's see. So if we go, let's just, okay, put that way over here. So that will take in signal 1 and whatever subtract it by 25. I need a splitter for that. Let's see. Oh, okay, hold on. I actually might need another one, won't I? Okay, wait a minute. This is a little bit confusing. A little bit confusing. A little confusey woozy. Let's see here. So we want out 1 to receive 100 volts if it's more than 25. So it's more than 25. So this will be 0 or less if it's not more than 25. This is an optional module. It is recommended only for advanced engineers experimenting with alternative circuits. Oh. Let's see. Put not inputs are more than 0. Okay, well, that does it then, because so if the signal is still more than 0, output 2 receives 100 volts. Let's see. So it only receives 100 volts. It doesn't even receive, like, it just receives 100 volts. Okay, so that fixes that. Output 2 checks the value of SRC1's after. If the signal is still more than 0, output 2 receives. Okay, so I think we'll need a splitter here. So we're actually going to need that signal again. So this one. Oh, we need a splitter here. Actually, so we got to use this. And then we use this thing. Put that there. Put that there. That there. And that one there. I think that's right. Let's see. Yeah, because the sun is going in here. Oh no, not you here. Because this one's going up here. Or we'll check if it's greater. And then this will toggle it if it's still higher or not. I don't know. Let's see if it works. No. Let's see, I put out 100, output 2 is 20. I was expecting 100. Oh, I gotta do a little bit more work. Okay. If the signal is still more than 0, output 2 receives 100 volts. So let's see here. If it's so this would be the condition if it's not more than 0. Okay, wait, I might have to rethink some of this. The signal is still more than 0. Output 2 receives 100 volts. So this is just checking. So that's going out here. What would we do? Not. You would want. The signal is still more than 0, so this is more than 0. So that's more than 0. It's 100. We'll combine them. And then what we can do is let's see, 100 volts. If it's 0, okay, I'm starting to get myself talked into circles now. They're starting to get hard. So this one. Hey, Ender the Explorer. Thank you for the shark. It's Shark Week. That's where we feed you to sharks. No, don't do it. Yeah, so this is the minus 25. And then this is going in here. Basically check if it's greater than 0. If it is, it will open this gate. Otherwise, it keeps the gate closed, and this is funneled into here. I might need to do a splitter here, because we're going to add one into the sum, basically to combine the signals. Now, if it is not, so this is still greater than 0, so this opens part way, which means this outputs a partial output. Am I? What's happening? Do I even need to do this? Because I'm getting confused now. Hold on, let's just see what's happening again. I'm just like, my train of thought just like died. I'm pretty sure I do need to do it, but okay. So output 1 received 100, output 2 received 20, but it should have received 100. Wait. Alright, so let's... I wish I could help. I've never seen this game before. It's fine. I want to do it on my own, okay? I want to be like, oh God, little brother from Strong Bad. I can do it on my own. So let's output 20. See, but we can see all the outputs at least, so that helps. Oh man, I remember when I used to have to like, or when I'd like be working on like a little programming project, you'd have to like go and debug all the things. It's nice that it just shows you everything. So it's 20. So 20 comes in, and then 20 is still greater than, okay, but we need to check to see if it's greater than, again, 0, not greater than 20. Or not just that, it's just, we want to make sure it's greater than 25 still. So how can we do that? We need a max or a min. Okay. This game I just found on Steam and it looked interesting. And I've been getting into puzzle games lately, so here we are. Okay, so plug that in there. I don't know if I need to put there. Definitely looks neat. I like the art style. Yeah. It's definitely a different approach to the whole, like, logic puzzle game genre, whatever, right? So, trying it out. Signal still more than 0. Should receive 100 volts. So, okay. So I think what I need to do. Okay, hold on. I got to rethink it a little bit. So this is just testing. Got a minus 25. Get 20. The SRC1 works fine, I think. Yeah, output 1 is okay. So let's work on output 2. It's hard to translate in my brain. Like, okay, I want to, you know, I gotta write like write the comparison in the. This is like assembler or something, man. Okay. Okay, hold on. Let's just get rid of this stuff for now. Okay, I do want the max module. But let's just work on one thing at a time. Okay. It's more than 25 volts. Output 1 receives 100 volts. So we do a sum. You know what? I'll do it. I'll do it the really long and insane way that will not get me a high score, but at least it will be. When I program, I tend to not like doing the hyper condensed code that a lot of people like to do. Oh, I did the whole function in one line. I hate you. If you do that, I hate you so much. I can't do it. So I should stop trying to do it. No, we're gonna do this the really long and repetitive way, but at least I can understand what's going on, okay? So we have a max module, right? We have, okay, so first we gotta do a sum. So compare that. There we go. So when the signal from SRC1 is more than 25, output 1 receives 100 volts. So output. So we want to check. Also smarter, not harder, as they say. In this case, it's just like legible versus like, like really super condensed, complicated mess. You know, KISS, keep it simple. But in this case, I prefer, like, I don't know, kill, keep it legible. Let's see here. So we subtract 25 from it. All we want to know is, so we want to know if it's more than 25. So this would be less than 0. Which is the OR. So if the input is more than 0, it outputs 100. So all we did was subtract 25 out, and we get 100 volts. So, and then that's what this thing was doing. Because then this was here, gating it. Outputs 100 volts if either inputs are more than 0. What was this one? If the signal is more than 0. Well, that seems to be basically what the OR does, isn't it? What? Hold on, am I... If either inputs are more than 0 volts, 100 volts is output. If the input signal is more than 0, the sum... Oh. Okay, no, I don't want that. So, basically, if this comes out to more than 0, we'll put 100 volts here to let this through. Because that's all we're going to do. Output 1 receives 100. So we want to just output 100. Well, actually, in that case, this could just go right to the sum module, I guess, at the end to combine the signal. Because, yeah, it's 100 volts. Okay, so we got the 100 volts there. That's done. Now, that's source 1 finished. Actually, I can just go right in. I need to use the sum module. Okay. So now, next step is we got to check if checks the value after it has been decreased by 25 volts. More than... Okay, wait a minute. Better see one. It's more than 25. The other problem is I'm like, oh, I'm like thinking it out in my head, and like my brain is... I almost need to like start like getting out the notepad module and start typing on it. SRC1 greater than 25. Which means it has to be greater than 0 in that case. If it's not greater than 25. So that's what this is doing. Okay, that's fine. It should be good. I wonder if I can just check anyway. I mean, it'll, yeah, output 1 is always good. Okay, output 1's fine. Okay, so now we gotta do output 2. Output 2 is a little bit harder. So now, we want to take the signal, so the sum module, so I need a splitter for that. You know what? I'm gonna put this OR module way at the end. That is the final, that is... You know what? I'll put it up here, actually. Get up there. There. It's out of the way. I don't need to worry about it. Okay, so now we got to split out the sum module so that we can use, so we can get another sample of it. Output 2 checks the value after it's been decreased. So that's, so we have the value of if it's been decreased. That's what we have right here. If it's more than 0, output 2 receives 100 volts. So that's what we're actually checking right here. So what we could do, that there, okay. So now, we want to check if it's more than 0, so... So that's what this tells us. And then we can use this thing. Because if it's more than 0, this will be 100%. So then output 2 receives 100 volts. So... one. Let me just use a not module to simulate that. Okay, so that's 100 there. Output. So then, so it's not more than 0. So this is a negative number. I wonder if we could use min instead of sum. No. Or max, I guess. Because signal's still more than 0. Output 2 receives 100 volts. That's what this is doing. This is just outputting 100 volts. Gated by if it's 100 volts or, you know. Let's see. Let me add that into a sum. Because basically it'll be, so that's good. It'll be 100 or 0 here. And then I could just put a 0 in. Well, I think 0 is like the default. If you used a min, that, because this basically will take either 0, it's either going to be 0 or a negative number. It's going to be the lower of the two. Does that work? I don't know. Let's find out. Yeah, it does. Fantastic. Oh, look. Some people found some ways to optimize that. I'm sure there are ways to optimize. I don't care. Good, things are starting to come together. Yay. Okay, now we're getting specs. We're getting the specs for the nuclear warhead. Oh, it's a radio. For the pirate radio station. We're going to make a pirate radio station. I'm going to calculate the farm's radio broadcast system. Why? You're going to need it for communications. Communicate with who? I can already talk to you. I'll explain soon. Get to work. Get to work, drone. Alright, SRC1 is source 1. Random signal with occasional voltage spikes. Voltage spikes are always at least 75 volts. That times that. Okay. Okay. So, probably need this thing. My constants. Actually, I guess it'd be negative 75, actually. Because it's going to be 75, so it's going to be whatever minus 75. Blip. 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 I mean, you know, I am using an extra board that I don't need to be using. I could just put it in here. Yeah, okay. So 75. If we subtract 75 out. And, the input signal is more. There we go. And that'll tell us. That says okay. So, guess we technically want a NOT gate, I guess. Is it a NOT gate? Oh yeah, you know what? I want the NOT gate for that. If the input signal is more than 100 or more than 0, it's module output 0. Module. Yeah, that's right. Because we're going to use that to gate this. So this is going to gate that. So basically, if this comes out to a negative number, or a 0 or a negative number, this will gate it down to 0. Right? Because if the input signal is more than 0, yeah, it's too high. Because I'm subtracting it out, so it'd be too high. And also output 100 volts. Okay, that should be fine. In fact, is that all it needs? Is that it? Yeah. Fantastic. Jeez, after that last one, this one was a lot easier. Oh, look at that. They got one more point than me somehow. It's like, oh, I managed to do it without anything. I just run the cable from source 1 to out 1, and it just works. Maybe that's the problem. You see, that would be like if it was, if it was like Apple computers or something. It's a terrible idea. We're just going to attract trouble. What's going on? Do you want to think people are going to hurt you? Gordon's just like, I don't want newbies. Stop arguing. It's what I've done to survive. To thrive. I can't believe this. He'll come around. What's going on? Tried to hear all the how explain it, but I'm saying it specs for the next. I mean, it's pretty obvious. It's not, I don't need to be a detective to figure that one. Oh my goodness. Hey, radio amplification circuit. Yeah, I can build an amp. This one's optional, strict. Okay. I know what the argument is about. I'm not that daft. It's obvious, like, she wants to, like, broadcast, like, our presence to the world so people will come and join the camp. And Gordon's like, you're just going to let everybody else come in and eat all the cream cheese. And it's like, well, yeah, it's true. There might be less cream cheese. Distribute signals to SR1 and SR1 to out1 and out2. If SR1 is less than or equal to 40, out1 receives SR1. I'm sure it'll be fine. And out2 receives 0. If SR1 is more than 40, out1 receives 40 volts, and out2 receives SR1 minus 40 volts. Okay, a little tricky. Let's see. Oh, we're going to need to split. Put this over here. So it's going to be the OR, right? So you subtract out 40 and out1 receives SR1. Okay, pretty simple. Let's see. Gonna need to do this actually. It's there. This goes there. I don't need the second one here. So there we go. So subtract out 40, and then I'll put 1. And output 2 will receive nothing. Won't even bother. Okay. If SR1 is more than 40, then out1 receives 40. another one. Use this one as a constant for 40. And so we want this to be the opposite. That's what the NOT gate's for. That's why God invented it. It was God that invented it, not an engineer. Okay. Let's do that. Put that there. And that one goes there. That one goes there. And then it goes in there. Output 1 receives 40. Do our sums. Gotta combine the signals. And then output 2 receives source 1 minus 40. It's this so we need another one of these. Split this. And let's see. This goes here, and that goes there. I think that would do it. No, everything's wrong. Let's see. Okay, well, let's what do we got? I like how it just shows red here. It's like, no, you failed. Okay. So we were expecting, what were we expecting there? 33. And output 2 should have been 0. Oh, yeah. I mean, yeah, that wouldn't work, would it? Why did I output 2? We're expecting 33 on both. We're expecting 40 on. Okay, hold on. So 73 is what's coming in. 73 is more than 40. So 73 comes in here. It's 33. So okay, wait. I see the issue. So 33 is greater than 0. It's greater than 40. So that comes in here. That says, okay, you can output your 33 volts, but SRC not doesn't receive the, okay. So I see one issue, which is we don't need that one. Put that there. Does that fix that part? No. It does not fix that part. Okay. Less than or equal to, then output 1 receives SRC1. Okay, but that's less than. We're dealing with a more than problem. So if SR1, source 1 is more than 40, one receives 40 volts, just flat 40. So So should that just be here then? No, it's still not working properly. Does work correctly that case, but then output 2 should receive 33. $33 is up here. It's regulated by this. But it was greater, so might have to start again. I don't know. Lock cables, lock controls, lock everything. Yeah, let's just start again. Too confused. Okay, so we need that. All right, let's just start. Let's work less than or equal to 40 volts. So we're going to work on that condition first. And we're going to try to... I'm just going to use more modules. I keep trying to, like, condense it, and then I get messed up. So we subtract out... get out of here. We subtract out 40, and we want to make sure... So it's less... So this is greater than 0. You've got this. I'm sure I do. Okay. Okay, so I'll put 100 volts because it's great. It's well, we'll test the. We're testing if it's less than, so it's not module. Less than or equal to 40 volts, then out 1. So it's less than. So we're 100%. We're doing something at 100%. What are we doing? Out 1 receives SRC1. So put that in there. Need a splitter. Actually, not yet. It's 100%. There. And output 2 is going to receive nothing. We'll just not worry about output 2 just yet. So it was less than 40. Okay, fine. So now more than 40, which means we actually need another NOT module. Because this is an OR condition, right? So or if else. 40 an out 1. So it's gonna be 100%. So that's there, that's there. And now we got to combine these because we only have one output. There we go. But it'll always be just 40 or whatever the signal one is because of the way the NOT gates are working. They're always going to be, these ones are always going to be inverted. If this one's 0, this will be 100. And if this one's 100, this one will be 0. Okay. 40 volts now. Output 2. And so this one, we want 2 of these. And we've got to split. Because we're doing 2 things. What am I doing? Why am I putting that there? Come on. So, this one's going to be the second one. And output 2 receives source 1 minus 40 volts, which is this original output, which is why I needed a splitter here. Like that, right? Let's see. Oh, okay, having some problems. Okay, getting closer. I like the little ball. So output 2 was supposed to be 0, instead it was negative 20. So yeah, so 20. What was output 2? Oh. Ha 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 ha. It's because I'm being a dumb. I'm being silly. Like that. Right? Yeah. Fantastic. Oh man, some people got a few extra points. I don't care. Never mind. Dot 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 dot. Whatever, man. Well, let's do the min-max redesign. Hey, one of our engineers came with this design for making spare min and max modules. In case you don't have enough, you'll have to complete the design, though, if you have time. Are you and Miriam still arguing? No, there's not much point. We can't convince each other. So I put her in the Venn diagram circle with you in it. You're both not cool. Ha 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 ha. That's what happened. Okay. Build min-max comparators. At each time step, compare SR1 and SR2. Send out the higher of the two values to out1 and the lower of the two values to out2. All right. So we gotta build our min-max by hand now. I'm pretty sure. Here, we'll put some splitters in. I have a feeling I'm gonna need them. So I'm pretty sure what you do is be the best way to do that. Just to think about it for a minute. Now, one thing is you gotta watch out for negative numbers, because if there's negative numbers, you got to make sure that you compare them correctly. So let's see here. Signals more than 0 volts. I guess I could see if the unit tests involved. They do involve negative numbers. Just good to check. Good to check. All right. But it's a good idea. I mean, you know that signals have negative numbers. You should design them so that they check for that. I mean, basically, and then you could have be the best way to do that. I'm just trying to think. Because they're both positive numbers. You just, take one and, invert it. but because you don't know if there's negative numbers or not, it doesn't quite work. I'm just trying to wrap my head around it now. What would happen if you have two numbers? If one was a... And basically what you'd want to do is know, okay, if you take one number and subtract the other number, would the result be higher than 0? That tells you. So, yeah, you know what? Negative numbers actually might not matter. I might be overthinking that, because all you really want to do is invert one of the signals. So it's a subtraction instead of an addition. And then you're basically adding them together. And now you want to know. And so if it's a 0, that means signal 1 is greater. This thing. I actually need 2 of these. And I already know what's going to be in the inputs for them. Signal 1 and signal 2. You're going to send the higher of the 2 values to output 1 and the lower of the 2 values to output 2. Okay, so basically, so you got to get the higher and lower and send them to different outputs. Okay, so no, you're not just sending one number. So just don't need that yet. The way I think of to do this is to actually set up both cases, and then you turn whatever one on based on the result. So that's what I'll do. Let's see. So these will be the final results. Although they're gonna... Okay, wait. Maybe I won't try going backwards. Okay, maybe I'll try to... So, we'll say signal 1 is higher. So, this would be above 0 then. Yeah. Signal 1 is greater, and that means this is going to be above 0. So... which would mean... So we'll say above 0. I need to split. Yeah. And below 0. All right, so above 0 means you're going to take 2 of these, I think. That's the only way I can think of to do it. Click, click, and then and 1, 2, and then below 0 means you do the opposite. I don't know. Okay. I'm like, why do I have extra? I don't. This... Oh yeah, you gotta. Blah 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 blah. My problem is you can't. Oh yeah, but you can use these as splitters, basically, or as mergers. So this is going to output 1, this one goes to output 2, but now in this case, you just switch them around, right? That's how that works, right? Sometimes. Sometimes that's how that works. Alright, let's see what happens here. Oh, 23 and 32. That's nice. Thanks. Okay. It's 23. 23 and 32. So that outputs 32 and negative 32. So 23 minus 30. I'm not. What am I doing? What's happening? Like that. Yeah, it works great when you put the wires in the right place. You even thought of it correctly. You thought of it correctly, but you didn't plug the wire in the right place. The wire was in the wrong spot. Let's see, rack space. Where did they get it? Cable length, time taken, 9 minutes. Let's see. 106. Somebody used 106. Those are certainly wires, lol. You put the wires in this place. You put the wire in the thing. Nice work. Sometimes implementing behavior on a module from scratch really helps you understand. Yeah, it's wonderful. It's wonderful. I know you hate me, Gordon. I know you do. I'll be right back. I gotta go turn off that thing. It's gonna keep beeping. No, let's take a little standing break. I'll be back in 5 minutes. 5 minutes. I'll put on some. Oh, yeah. Okay. I'm like, my microphone still. I'll put on some Return of the Obra Dinn music. This game's so good. I'd play this on stream, but it's like super gory. We'll talk about it later. Okay, I'm back. Yeah, Return of the Obra Dinn is really good. Probably talk about it later, maybe on Monday. This game requires way too much thought for me to try to talk about it now, but suffice to say, it's very good. All right, gotta make a radio clocking system. Right, I suppose you should reserve some sort of explanation, I guess. Yeah. We sent you out there to reclaim the farm. It wasn't just to provide food and housing. We already have enough. The farm you're reclaiming is a second generation Ellis Agritech solar powered radio broadcast system. Far more powerful than the one we have on our home farm. Well, he's sent a broadcast to who? Everyone. Everyone in our vicinity. Anyone needs a home or just a friend. Announce our location. Announce anyone who wants to trade with us. I want more than just survival. I want for us, all of us, to thrive, to rebuild. We can't do that just farming, eating, and sleeping over and over again. And why does Gordon object to this? He's gonna run out of cream cheese. Yeah, he has his own reasons. You don't know. I don't even talk to him. He believes we'll attract enemies. That's your call, right? Yes, and also my responsibility. So that now. We continue working. Our broadcast system's clocking system is broken. Without it, we can't tune into the right broadcast frequency. Time to fix it. We'll send you some clock modules. You'll need those. Oh, great. Can you just lock it with this? That's interesting. Clock modules output trigger signals at regular specified intervals. These signals can be used to trigger other modules. Output 1, output 2, and output 3 receive clock signals at different intervals. Oh. Looks like output 3 is always the opposite of output 1, so we can save a little bit. So output 1, output 2, and output 3. Let's see here. So 1, 2, 3, 1, 2, 1, 2, 3. So maybe it's 3. Oh, sorry. This one's 2. This one's 3. And I need a splitter. Put 1 goes there, that goes there, and that one goes there. Like that? Yeah. Whee! $16,990. Let's see. Somebody used 12 modules. Cables used. I used one more cable. Probably because I decided to split it instead of not splitting it. Or I decided to, I had to split it to do the knot thing. Doesn't even really save you a module. I like how my cable length is like super long, so I put all my modules over there. Good work, Gordon. We'll send you the next specifications. I expect he wants to share his opinion with you. Is his opinion worth listening to? I disagree with him, obviously, but I respect him, and so should you. He has valuable perspectives. Does he? I don't know. I don't like Gordon. A radio memory buffer. We never did tell you why Miriam appointed me lead engineer, did we? Is that relevant? I am incredibly familiar with Ellis Agritech equipment. Pretty useful working on farms filled with their stuff. There's a reason why I know their equipment. I used to work for them in the old world. Yeah, not like you. That's what he's saying. Yes, those machines you've been working on, I know so much about them because I helped build them. Why did they break? Why did everything break? The truth is, I don't know. I wasn't executive level, so maybe these machines have secrets I don't know about. Maybe it was something outside of these machines. It's a mystery for me, too. What's an Ellis Agritech? The biggest manufacturer of agricultural equipment in the old world. There used to be so many companies like it. Then its founder, Eldon Ellis, came along, and he swallowed them all. You know how he did it? Own the entire market? How? Ellis's equipment was state-of-the-art, sure, and he priced them accordingly. The farmers couldn't afford it. But if they didn't have his equipment, their crop yields lost out to those that did have them. So Ellis gave them an offer. He'll rent out the equipment, and in return he got a cut of the revenue. Of course, as time went on, the more equipment they had to loan, the more profits he got. He practically owned them. This is just how modern agribusiness works. What? Okay, business. Sounds like you're talking about the monopolist. I mean, but it's just like... whatever, it doesn't make any sense. It's fine. What's it have to do with Miriam's plan? That's not, Gordon, I can't talk to you anymore. You're creeping me out, Gordon. Because Ellen Ellis is still out there. He still has some employees with him. He promised them refuge from the chaos, and they stayed. Free broadcast. He will be listening. He's going to try to claim what he thinks is his. And that means our farms. What? Why doesn't he just come and get the farms anyway? What, like because they're repaired, he wants to get them now? Like what? He can't repair his own equipment? What's happening? Okay, yeah, it's not your call. Whatever. Yeah. Next step is fix a memory buffer and loop it to broadcast along with the clock modules. We sent some sample nonsense. Gordon, I think Gordon doesn't know what he's talking about. I think he's just trying. He's just fear mongering. He's like really good with. He's really good with numbers, but maybe he's like a conspiracy theorist or something. Oh. See, output 1 receives memory buffered signals from SRC1. At regular intervals, the memory buffered signal is updated to the latest signal from SRC1. Let's see. Stored value sent to the output until a different value is sampled. Interesting. Current memory value sent to the output. Okay, interesting. Looks like 2. So, have a clock of 2. Basically, every time 2 happens, it goes to the gate. It goes up there. It goes up there. Right? Exciting. Fantastic. It's done. The broadcast system is ready. What now? Now I'll record our message and you will broadcast it. Are you ready to receive the recording? Sure. Begin recording. Hello, fellow survivors. I am broadcasting from the abandoned farmstead north of some highways. We are a community of survivors who have survived this new world through collaboration and cooperation with one another. And we'd like to invite you to join us. If you are out there, a lone wanderer, just scraping by. Find us. We have a home. It's so this is just Fallout. This is just Fallout now. Are you a lone wanderer? Maybe the lone wanderer will come and save us from. Will come and save us from. From the. From Gordon. I hope so. The tractor security system. Well, that's happened. Hopefully nothing bad happens. Yeah, hopefully. We should get back to work. If we do get our survivors, we best be prepared. The vehicles, we need them to till the fields, planting and harvesting. We can start with the tractors. Turning them on requires a key code, but we can hack them. We can be a master hacker. Another settlement needs your help. I'm gonna quit out of this and load up Fallout 4, and then I gotta go like destroy Gordon somehow. Okay. Output 1 receives a clock signal with an interval of 6 timestamps. Okay. Yeah. Alright, well, that's simple. Oh, interesting. You can only have 5. Okay, well, yeah, that's a problem to solve. Let me think about how to do that. Well, what you do, you need number like 2 and 4 add up to 6, right? So we just go 2. You do another one. It's 4. And you do an and. There. That'll do it. Because now, only when they both pulse will it go out. Math! We did it! Okay. Output 2 receive signals from SRC1. Oh, and then we're doing the... Okay. Da, 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 da. That. Okay. Not quite. Regular intervals. Six. Oh, I'm not. Okay, hold on. I'll put 1. It should be. Yeah. Oh wait, what am I doing? I'm being dumb. That's not gonna work because although that would go off on the 6th one, it's also gonna go off. It's just gonna go off on every 2nd one or every 4th one. What am I doing? No. I did that wrong. What am I doing? Okay, no, that's not how you do that. 6. see. What do we got here? Pulso 1, you gotta still wait 1 interval. I must disappear and search for the elusive treasure known as sleep. Thanks for the stream. No problem. Thanks for hanging out. Have a good one. I don't know. Tricky. Five. I think, yeah, no, maybe that would work. 3 and 2. Yeah, no, because I had the right idea, but 2 and 4 is divisible by 2. I think they can't be divisible by each other, right? Because then, when they both pulse, it'll only be on interval 6, the lowest common denominator. That's, not each other. Because you need 2 factors that are 6, but that's the lowest common denominator. There. Does that work now? Well, getting closer. Yeah, so I put this in. There. Magic. Had the right idea. Just had to figure it out a little bit. Let's see. Rackspace used 66. Somebody used 16 modules. That could be a fun challenge. Try to see if you could use as many modules as possible. Tractor's improvement. Some improvement you could make. Okay. Wonderful. Do I have more optional ones then? I have more optional tasks. Oh my goodness. Oh, I need a music player. Well, here's a fun distraction. The tractor has a music player. Oh, nice. Yeah, go get it fixed. Listen to those fat beats. Thanks, Gordon. Make a drum beat. Out 1 is a kick drum, and out 2 is a hi-hat. Out 3 is a snare drum. Okay. Let's see. So output 1, 1, 2, 3, 4. So output 1 is 4. Output 2 is just a regular 2. One, 2, 3, 4. 2, 3, 4. So, and this one is offset. It's 4. It's a 4, but it's offset. The first one's offset. Wonder how you do that. How do you offset it? So it's 4, but how do you offset it? I guess you can use... Oh, we don't have that. Okay, well, I thought maybe the gate would do it. Or maybe it's not actually an interval. It is an interval, but that's not actually the right way to think about it. It might only be when 1 and 2 are negative. When 1 and 2 are both 0. Let's try that. I think that's what it is. Splitter. Okay. Splitter. So these ones can go here. Both. And then what we'll do is we'll take a sum and run that through a NOT gate. Like that. What's that? Nope. Let's see here. Oh, you know what? 2 is offset too. Let's see here. Like that. Ooh, fancy. Nice. Send some recordings over when you have the chance. We're just for me more music. I don't know. The music library on this thing's pretty dull. Doesn't matter. Send us something. Anything. Man, Gordon's so bossy and pushy. I'm really like scared. I'm getting scared. This tractor was one of the things I worked on at Ellis Agritech back then. The gear switching system was never as efficient as I hoped it would be. Why not? According to Eldon Ellis, it was good enough. No need for future further improvement. Oh, this sounds like real high-tech machinery. Just like, oh, whatever. You cornered the market with this, huh? Didn't have to be the best. It just needed to be better than the competitors. We always make the improved version later and sell it as new and improved. Can we improve it? Well, yes, of course. I thought you'd never ask. Okay. Out 1 is a alternating signal of constant frequency. Yeah. Output 2 alternates between 2 clock signals with different frequencies, 2 and 3 timestamps. Which clock signal to send to out 2 is decided by out 1. Let's see. A constant free. Okay, so it is like a 1, 2, 3, 4. So what you're gonna do? Have this thing. Okay, how's that gonna work? So it's a NOT. They're getting vague with the directions now. Okay. So... you can copy it? Oh, that's cool. Okay. Okay, now you know what? I think I see how it works. So what you want to do... so interval 4 is the gate, is the gate. So we do want that because it does pulse that. Now, yeah, that is basically what you got to do. But a little bit more complex than that. You basically want to take the, because you want the initial output to be on. So I guess you just take the, whoops. Not output. And then yeah, like that. That should work, right? Potential infinite loop. Let's see. Because I want this to go infinite loop. Okay, fine. I won't do it that way. How else could I do it? Will that at least get rid of the infinite loop issue? It's basically the same thing, isn't it? Okay. See, 0, 100, 100. Oh, you don't want to split the output there too. Lol. Split that. And then one goes here. And one goes here. Like this. I guess you don't really need this board. Let's see. No. I wonder. So I need the gate to be Okay, wait. Let's just do a... output 1. Okay, but then output 2 went to 0. Why did it go to 0? Oh, because this is putting in... This is still outputting the inverse. Let's see the... Okay, hold on. Take apart this stuff. Get out of here. I don't know, maybe I don't need that. It just always outputs on. There's nothing going on the in. There's... Wouldn't be a sum. You just want the opposite. But no. That's why you need this. You need to be triggered with this thing. But if you put this in there, it gives you an infinite loop warning. I'm not sure why, because it's not really an infinite loop. Yeah. Doesn't like that. I put a card in between it. Does that help? No. There's something I'm missing. Oops. What's that? No, just creates an always on. Because, yeah, I have to get the input in somewhere. So that's there, that's there. So when I pulse the gate, I mean, I would like the signal, basically it's outputting 100, so I want the signal to be 0 coming in, which is what that would do, but I can't do that for some reason. Okay, hold on. So if I put the output here, but then wire it to this thing, with another NOT gate. Nope. Just won't let me do it, but that's what you need to do. You need to be able to buffer the signal. And it needs to be responsive to the current output of the signal. So and I recognize what this is. This is a latch, but I've always been freaking crap at trying to figure out how to make latches in Logic. It's not helped when, yeah, like it does need to be responsive. That's the only thing I can think of. The only way I could think of to do it. Okay, wait. No. Hold on. There is another way. Mate, no. Because... Yeah, no, it needs to be a part of the input. It's the one thing I can think of to do it. When the input switches, like when the signal's active, it needs to be getting an input, a null input. And then when the signal switches to null input, it needs to be getting 100. It needs to be getting an input. So if it needs to be responsive to it, how... am I going to have to get a hint for how to build this thing? Or how it wants me to build it? I mean, I have an idea of how to build it, but it doesn't like how I want to do it. Okay, wait. Wait a minute. Maybe there's another way. I don't know. There's an idea percolating in my brain, but it's like in that process where it's just kind of like bubbling up, and I'm just like, I'm not quite sure I see anything yet. What if... Okay. So this will be my always on one. So let's see if it's all... okay, so that one's always on. And then if I built another one... well, I can use the same... I should be able to use the same one. I mean, I guess technically you could just split this output. So that one's always on. And then when the 4 oh yeah, it just moves it one step down though. So I'm just like, okay, when the 4 interval hits, not, I mean, pulsing the gate on this doesn't do anything. Okay, wait. Because, yeah, pulsing the gate on that doesn't do anything. What am I doing? This has to have an input. It just does. And the first input it needs is, because it needs to start off as on, it'll be an invert. Because I want it to have a signal. So let's start with that. Okay. And this 4 pulses the gate. It's probably still going to cause an infinite loop, isn't it? Because this is just always going to output a steady signal. When the gate, so when this thing pulses, we want to change this to want this, if it's not on, we can't really pulse the not, that's just gonna pulse, that's just, yeah. Pulse the if there's a signal, you don't want there to be a signal, and if there isn't a signal, you want there to be a signal. So I guess you need a second not. And that controls this. That's just infinite loop again. It's the same thing. You're just not allowed to have the input be influenced by it, but I don't know how else you can do it. Every 4 ticks, it switches. How can you make it so that every 4 ticks it switches? I don't even know what's going on with the bottom one. That was... Oh, you know what? I think I might understand output 2, but we gotta figure out output 1 first. I don't know. Clocks, switch it. No. wonder if that would work. But it might not result in an infinite loop. That I don't know. Okay, hold on. We're gonna try something a little bit different. A little bit different here. Just garbage. Just everything go away. Okay. Oh, I don't even have those. Never mind. I mean, I had an idea if I had those number ones, I could probably try to like do maybe like a increasing sum or something. And then when it gets high enough, it can switch the signal, but sadly not.
I initially thought you were mixing the music that's on the game.
What?
It looks like a little music thing.
Well, yeah. Mixing the music on the game. That's ridiculous. I'll be done soon. No, just 10 more minutes. Let's see. So you can't. So I thought like maybe doing like an increasing sum would work to get around it, but that I can't do that. So all I have are binary modules. I'm not sure what else I could do to get around that. Not seeing a way. Let's see. Yeah, you don't even get an inverter or anything, so it's like, well, this is what you got. Well, if you... Okay, hold on. If you'll put one here. No, because anytime you need to switch the signal, you can't. You get infinite loop. I don't see a way to do it. That's can I do the hint button? Where's the hint button? I need a hint. I know that. Tell me how to make... There are clock signals. Use the clock signals, generate them. Yeah, I know that. The problem is I can't use... Give me another one. Store the clock pulse in memory for out1. Yeah, obviously. But you can't even really store it. Wait a minute. No. I might... How do you do that? What adds up to 8? 4 and 2 would be 6. 4 and 3 is 7. 4 and 4 is 8, but I can't do 4 and 4. Wait, it's not... Is it 8? Well, it would be, because I could make it so that on pulse 4 it's active, but on pulse 8 it's inactive. And I can use the storage thing to store it. But the problem is I can't think of another way to differentiate 4 and 8 that doesn't differentiate between 4 and another number. Because 4 and 2, that'll just be 4. And it'll differentiate between 4 and 2. And these don't go up to 8, so I can't do that. 4. That's this whole stream. Brain work. Let's see, 4. No, it won't do anything. I'm just like, my brain's like why don't you do like 2 sample modules and you can alternate between it, because that doesn't work. That's still the infinite loop problem. Keep spamming the hint button. But that doesn't work. Use logic modules to toggle between clock singles. How? Huh. No, I mean, I'm pretty sure I could just Google this and figure out what it is that they're looking for. It really sucks to have to do that, though. But I might not be able to figure it out. I'll give myself a few more minutes and I'll do that. Let's see. Yeah, you still need... Wait, maybe I've got it. Maybe. No, that won't work. Will it? No, because if I have... Well, you need to change the input. And you get the infinite loop problem if you try to change the input with the result of an output. So if you have an output to input, we can hold it. The problem is I can't. No, I'll have to look that one up. State. Yeah, I know it's a flip-flop. Gate inputs. Sound. In that example, one sample hole. China. The biggest problem here is the in-game hints. We're stuck on how to make a flip-flop. Since using the immediate inexperienced solution rightfully leads to a loop. Well, okay, well, thank you for insulting me while explaining it. Let's see. For tutorial levels. Previous state. Okay, so hold on here. So this stores not the value. And then when it pulses, they should switch, right? That? No? Does it? That one just stays at 0. Yeah, because the input never changes. But I'm pretty sure you can't... And then this is just, as they say, the inexperienced solution. Because, you know, if I designed computer chips, I would know what to do. This is just infinite loop, isn't it? Yeah. I'll explain later. Buffalonium's like, what's the point of this game? What's wrong with you? Why aren't you playing a game that's actually fun? I don't know, okay? Let's see. I'm just going to look up the answer so I can understand, and then I'll try to figure out what's going on. Because... all right. Let's just set this up, and then... Oh, what? You can move this around? Oh, I didn't know you could move that around. Okay. So I'm just going to set up the solution that they have, and then I'm just going to look at it and try to figure out what's happening. This is already crazy. Let's see. Oh, this isn't the right one. What am I doing? I'm like, what? This doesn't make sense. Oh no, it's the tractor gear system. There we go. All right. So clock 4. So it's going into here. those off. All right. Memory thing I got. So this is just the whole solution, but I'm gonna put it in and try to figure out what I don't understand, because there's something that's just escaping me. I don't know what it is. Not those. Two of these. Some. Oh, you can move that around too? That's cool. Okay. So this one goes to that. This one goes to gate. Bottom one goes to the end here. This one goes to here. Goes to there. Okay, that one goes there. Goes there. Here, let's see. Out. Not gate. This output goes to the gate here. All right. So that's the solution. Jeez. So let's see if I can figure out what I'm doing, what I'm not getting, just so that I can learn something. So okay. So this pulse is in. Pulses 100 into the input there. 100 down to the NOT, which outputs 100 to here. And then 100 to this NOT, which is 0, which goes to the gate here. $100 goes to the gate here to pulse that one. This gate outputs to here, which outputs to all this stuff. Mainly just concerned with that output. So using an AND gate and let's see here. Doesn't link in anywhere. So this goes in here. And and that output is here. So this is the one that's storing, because now when I go next, the AND gate flips. But this one remains at 0. Now, because it's at 0. Next time this pulses, this is going to flip this. It's a flip-flop, right? It's basically a switch that triggers, that switches states. And one of the basic building blocks of RAM, of computer memory. Yeah, I was scared it would get to this, and like flip-flops, I honestly have a hard time getting my head around. So it looks like this. It's now 0. This is still 100. Where does this output go? Into the input here. It's here. Yeah, but it's never actually doing an infinite loop because you're using the AND gate to negate it. So when it switches, this pulsed in, and then that turned off the feed here, which turns out the output here removes this signal, even though this went through. Yeah, because it's 2 NOT gates. Interesting. Huh. Bleh. Well, I'm going to wrap up for now. But I'm definitely going to have to puzzle over that myself. And I think I can get like an intuitive understanding of it. All right. That's enough of that. But yeah, I'll have to puzzle over that because I can get that in my brain. I'm fairly sure I can. It's just takes a little bit of work. But thanks everybody for hanging out, and I'll see you all next time. Bye for now.